Alright, let's move on now to number 5. Okay, so we've been given this cuboid. We need to calculate the length of AC, that length here. Well, because it's a cuboid, then all of the angles must meet at 90 degrees. So we can see that we've got a right triangle. In order to find the length of this length x, we'd need to use the Pythagorean theorem. Anytime you got a right triangle with two sides, you find the third side with the Pythagorean theorem. And so 22.5 squared plus 30 squared, a squared plus b squared equals c squared. So our hypotenuse, x squared. And so let's work that out. 22.5 squared plus 30 squared is big number. So that's 1,406.25. And then we'll take the square root of this number in order to find out what that hypotenuse is. X is the square root of 1,406.25. 37.5. It turned out to be a nice round number after all. In part B, calculate the size of angle GAC. GAC. Okay, in order to find that angle, I first have to determine, is this a right triangle that I've just created? GAC. Let's complete the triangle there. Is that a right triangle? Well, observe that this length right here is along the flat base that's sitting on the floor of this box. The floor is, of course, a horizontal line. Even though this is kind of sort of being rotated with the back corner away from you and this rotated towards you, it's still horizontal on the floor. And the GC is still a vertical that must be perpendicular to the floor. And so now we know where our right angle is, we should be able to use SOHCAHTOA in order to be able to find the angle. And so relative to this angle, I've been given the opposite side, which is 40, and I've just learned a moment ago what my adjacent side was, the x of 37.5. So when I've been given opposite and adjacent, I'm going to use the tangent ratio. So the tangent of this angle, I'm going to call it A because it's at point A, is equal to the opposite over the adjacent. In order to solve for A, I need to take the tangent inverse to untangent it and get the A alone. The tangent comes to the other side and becomes its inverse operation, tangent inverse. 40 over 37.5, and your A, so let's see, the second of tangent to get the tangent inverse of 40 divided by 37.5. And that, oh shoot, I didn't quite type it in right. By a little handy feature, second enter brings up what you just did, so you can quickly go in and correct a mistake and then do it. So 46.8 degrees when I round to 3 significant figures. Number 6. So I've got a diagram with a crane that carries a flat box. PQ is vertical. The floor is horizontal, so obviously these are meeting at a 90-degree angle. Given that PQ is 11.1, that's been labeled, QR is 7.8, that's been labeled, PQR is 102 degrees, labeled, and RW is 6.5, also labeled. We need to calculate PR, this length here. Well, this forms the third side of a triangle. Let's look in this triangle. Is it a right triangle? Obviously not, because one of the angles is greater already than 90 degrees. So we can't use SOHCAHTOA. We have to use the law of sines or the law of cosines. Do I have an opposite pair? No, I do not. There's no way I can find an opposite pair. The only given angle has this unknown side. I need to find opposite it. So because I don't have an opposite pair, because I've got SAS, I need to use the cosine law. Cosine law, then, let's call this thing x for a moment, and we'll say that x squared equals the other. So this is kind of like the Pythagorean part of it. But because it's actually not a right triangle, I now need to subtract 2 of the sides that I just wrote down and the cosine of the contained angle, 102 degrees. And then, of course, x is going to equal the square root of all of that stuff. And so that's going to be approximately, let's figure it out, the square root of, here we go, 11.1 squared plus 7.8 squared minus 2 times 11.1 times 7.8 times the cosine of 102 degrees. 14.83. Does it say to how many decimal places? No, so I guess I should give it to at least 3 decimal places. 14.8, or if you want to be a little bit more precise, 14.83 meters. There you go. And we now need to find angle PRQ. That's this angle right here. So angle PRQ, well, that's also part of that non-right triangle. And because we now have the value of x, we now do have an opposite pair. So we could find this angle by using the law of sines. So the known ratio, sine of 102 degrees over its opposite side, which we just figured out is 14 point. Now I'm going to be a little bit more precise. I hate to use rounded numbers, so I'm just going to add yet another figure of precision. So I'm at 5 significant figures. And this is going to be equal to the sine of the thing I'm trying to find, why don't I call it theta, over its opposite side, which is 11.1. Let's cross multiply. 11.1 times the sine of 102 degrees is equal to 14.834 times the sine of theta. To get sine of theta alone, I'm going to need to divide both sides by the 14.834. So I still have on top the 11.1 sine of 102. And now to get theta alone, we need to bring the sine to the other side where it becomes a sine inverse of all of this stuff that I just wrote. And if I type this into the calculator, sine inverse of 11.1 times the sine of 102 degrees, close parentheses because my angle is finished, divided by 14.834, close brackets to finish my sine inverse function, and I get an angle of 47.048 degrees. It's bigger than I expected actually, but I guess I'll go for it then. So we get approximately 47.048 degrees. That makes me a little nervous because obviously that's very close to 47.1 and very close to 47.0. So I guess we're around 47 degrees anyway, but you get the gist. 47.0, just about. Okay, part C, the height h of W above M. In other words, we're looking for this distance right here. Well, if I could find the total height from R all the way to the ground, well then I'd only need to subtract the 6.5 and I'd be done. To do this then, perhaps I could make use of this 11.1 that I've already got, and I'm going to draw the rest of the way up. And if I can find then the height that R is above the ground, I just need to subtract the 6.5 and I'll have that height. So to find this height that R is above the ground, let's actually find this height. Maybe I should change color. It's getting a little bit crowded here. So I'm going to find this length right here. So I've already got the 11.1. That's helpful. So I guess I just need to find this length. I've already got this 7.8 measure. And this is 102 degrees. So I guess at the 90 degree point, if this was 90 degrees, that would mean that there's only 12 degrees left over above, so that it creates a total of 102 degrees. If this is 12 degrees, then this must be 88 degrees. Okay, so I've got, oops, I'm sorry, that's not right. It must be actually 78 degrees. There we go. So there we go, I've got a 78 degree angle and a 7.8 hypotenuse, and I'm trying to find the adjacent angle. Let's call it, for the sake of argument, I haven't used x in this problem yet, have I? Okay, let's call it an x. And so then we've got the cosine of 78 is x over 7.8. So the cosine of 78 degrees is x over 7.8. That means that 7.8 times the cosine of 78 degrees is equal to x. 7.8 times the cosine of 78 gives us 1.62. Wow, that's astonishingly small. At least, I guess the diagram isn't very to scale, is it? Hope I haven't messed up at some point along the way. Maybe you guys are going to come in and tell me I made a massive mistake. At any rate, x is 1.62, and now let's add it onto the 11.1 that I already had. So 11.1 plus 1.62 gives me a total of 12.72, which I guess I could round to 12.7 if I wanted, and that's of course measured in meters. And so if the entire height is 12.72 meters, then I just need to subtract the 6.5, and I'm finally done this problem. 12.72 minus 6.5, and oh, it's good that I kept that extra degree of precision, isn't it? Otherwise I would have not been at 3 significant figures. I'm at 6.22, and I hope that that is the answer given in the mark scheme. I don't have time to go over and check, I'm afraid. Alright, number 7. Got a hexagon. All sides have got a length of 4 centimeters. Now the interior angles of a hexagon are all equal, and so if you imagined completing this hexagon, all of these 360 degrees split into 6 equal pieces makes them 60 degrees apiece. So it says to calculate the value of angle ABC. So if this is 60 degrees, and obviously these angles will be the same, so the remaining 120 degrees has got to be split equally. Turns out that you get equilateral triangles everywhere, which are all equal to 4 centimeters in length. And so angle ABC, this one right here, must be equal to, ABC is this and this, isn't it? So it's 60 plus 60, we get a total of 120 degrees. Alright, given that OB is equal to OC, which we can see already, find the area of triangle OBC. So we're looking for the area of this triangle. So, well, we've got 4 centimeters. We've got 4 centimeters, so 4 centimeters, 4 centimeters, and a 60-degree angle between them. We know how to find the area of a triangle when that's the situation. We've got two sides, and the angle between them. We go 1/2 times the product of the sides times the sine of the angle in between them. So let's see. 1/2 times 4 times 4 times the sine of 60 gives us 6.93, and our units here is centimeters squared. And lastly, we need to find the area of the whole hexagon. Well, obviously there's 6 of these triangles, so 6 of these 6.93. I'll just multiply. In fact, I'm going to multiply my actual answer, which was more precise. I'll multiply that by 6, and it gives me a more precise answer here, and I get 41.6 centimeters squared when I round to 3 significant figures. And the last problem you've been assigned is number 8. Raoul, directly across from Sylvia in house S. So here's Raoul, here's Sylvia, 2 kilometers apart. When they are both facing north, they see a speedboat. Raoul in house R can see the boat at 35 east of where he is facing. So this is 35 degrees east of him facing north. Sylvia sees the same boat at 65 degrees west of when she is facing north. Okay, so there, we filled in the diagram. We've done part A, 35 degrees, 65 degrees. We need to calculate the size of RBS, this one right here. Well, one clever way to do this might be to, drop a perpendicular right here. Because this is also facing north-south, then we have alternate interior angles, because these are parallel lines. And so the 35 degrees must be equal, this must be also 35 degrees. Meanwhile over here, the 65 degrees alternate interior angles, this must be 65 degrees. So we've got a 35 degrees on the left, we've got 65 degrees on the right, and that gives us a total of 100 degrees, our answer to part BI. At this moment, how far is the boat B from Raoul's house R? So we're looking for, let me get rid of some of this junk now. So we know that this is a 100 degree measure, and we're being asked now to find out what this distance is, the distance between the boat and Raoul's house. Well, we don't have a 90 degree angle here, it's not a right triangle, so we have to use either the law of sines or the law of cosines, but look, we do have an opposite pair. And if this is 65 degrees, then subtract from 90, that means that this must be 25 degrees. So I now have enough information to set up the law of sines. The sine of 100 over its opposite partner, which is 2, must be equal to the sine of 25 degrees over its opposite side, which is x. We'll cross multiply, and then we need to divide both sides by the sine of 100. And let's see what we get. 2 times the sine of 25 divided by the sine of 100. And our answer is, of course, going to be in kilometers, 0.858 kilometers. It says I'm supposed to give my answer to the nearest 100 meters, so 0.858 kilometers, which is equal to 858 meters. To the nearest 100 meters, that's approximately 900 meters. Raoul and Sylvia then see a sailboat on the lake at point Q, which is 2.6 kilometers from Raoul. So that's 2.6. And 3.5 kilometers from Sylvia. I'll get rid of all this other stuff we don't need anymore. So there's your sailboat now at Q. We need to calculate the angle of RQS at that moment. So, well, we've got the three sides of this triangle RQS. We just need to calculate the size of the angle here. Because we don't have an opposite pair, then we have to use the cosine rule. And I suggest that you use the rearrangement of the cosine rule. So that would be that the cosine of Q, so the rearrangement is the one with the cosine of the angle already isolated, is going to be the other two sides squared added together, minus the opposite one squared, all divided by 2 times the first two sides, the ones on each side of the angle that you're looking for. And then we're going to take the cosine inverse of all of that stuff, so cosine inverse of all of that stuff, to solve for Q. 2.6 squared, 3.5 squared, minus 2 squared. And you know, I realize now I should have opened another set of parentheses at the beginning of this expression, because so let me just insert another parentheses here, because all of this stuff here has to be treated as the numerator. This is a classic mistake that students can make. They understand conceptually what's going on, but then they make a careless mistake regarding the use of parentheses. So we have to take all of that numerator and then divide it by this entire denominator, which is 2 times 2.6 times 3.5. And then we can close off the denominator. And now let's close off the cosine inverse function that opened this entire thing. And our angle Q is equal to 34.4 degrees. And that's the end of the review. Good luck studying. We'll see you in the quiz tomorrow.